Hi friends, welcome to my channel PSU Aspirants. In this video, we will discuss buck boost converter from GATE and ESE exam questions point of view. So, to stay updated with my latest video, subscribe to my channel PSU Aspirants. Let's begin. This is the last DC to DC converter in the GATE syllabus. Let's start with the circuit of buck boost converter. So in circuit, Vs is the input voltage DC source. S is the switch which makes on and off at very high frequency. This L is inductor which is connected in parallel with source and switch. Now very important thing that is new in buck boost converter is this diode. It is arranged such that it only conducts from right to left direction. And this is normal DC load connected in parallel with capacitor C so as to reduce the ripple in output voltage. Now let's see what happens when switch becomes on. So when switch is on, this positive terminal of the source gets connected to the negative N junction of the diode. Hence this diode gets reverse biased, and this due to that it does not conduct. So this whole part of the circuit gets isolated. Hence the current that is flowing will charge the inductor and it only flows through inductor. Now when this switch becomes off, inductor has gathered current in up to down direction as shown. So this inductor will now wants the path to allow the flow of the current which is already flowing through it. So inductor, when the circuit gets off, the source gets disconnected. So the path that is available for inductor to allow the flow of direction from up to down will be through this capacitor load arrangement and the diode. And as the diode is positioned like this, it will allow the flow of direction of inductor current through it from right to left that I have shown in here. So in off circuit, inductor will discharge itself through capacitor load and diode. Now let's look at switch arrangement. It becomes on for some time and it gets off for some time. So if we define D as the duty cycle, which is T on upon T. T is the total time of the cycle, T on plus T off, then on time is equals to dt and off time will be equals to T minus of T on is T off. Now we will see the basic parameters which will help us to solve GATE and ESE problems. So first parameter is VL, voltage across the inductor when the switch is on and when off. So first thing, when the switch is on, VL is equals to the difference between positive and negative terminal voltage, V plus minus V minus. So during on circuit, positive terminal equals to Vs and negative is 0. So VL is equals to Vs minus 0 equals to Vs and is positive in nature. Inductor voltage VL is positive during on cycle. Hence, according to the equation, VL equals to L del IL by dt. Del IL is positive. Hence, inductor current increases during the positive cycle from its minimum value to maximum value during time 0 to dt. Now let's look at the off circuit. Now buck boost converter off circuit is little bit different as compared to others. So let's see what is happening actually. During the off time, the inductor current is flowing like this from plus to minus like this. So it will enter the downward plate of the capacitor like this in upward direction. So it will make this plate, downward plate, positive and the upward plate equals to negative. Hence the VC voltage will have the polarity like this. From downward it will be positive and upward negative. So if we will take the output voltage across this R load, then we will get negative value, because downward plate is actually the positive. So what we will do, we will take the output voltage like this. This we will call it positive terminal and this we will call as negative terminal. Hence we will get the output voltage as positive one. From the positive plate of the capacitor we will connect positive polarity multimeter, and from negative plate of the or upward plate of the capacitor we will place negative polarity multimeter, and then we will get positive output DC voltage. So the VL during the negative cycle will be this, from VL minus VL plus minus VL minus. So is equal to 0, because this is ground. We will take negative terminal as ground. So negative terminal will get connected across this positive polarity of VL. Therefore it will be 0 minus of negative terminal voltage V minus equals to V0 plus V0. So 0 minus V0 is equal to minus V0, and that would be negative. That's why del IL, change in inductor current, would be negative, and it discharges during the negative cycle and its value will decrease back to the value IL mean at the end of the T. Second parameter is the output voltage. Now we will see how the output voltage theoretically comes out to be negative, which I have told you earlier. So we saw that Vs is equals to L del IL upon dt for on time. So from A we will get same equation putting dt that side. Similarly from off equation we will get same thing, minus V0 1 minus dt is equals to L del IL. From these two equation we eliminate this L del IL terms. So we will get Vs dt is equals to minus of V0 1 minus dt, and hence final output voltage equation we will get, that is V0 is equals to minus Vsd upon 1 minus d. So the thing that is to be noted is, first, V0 is minus negative in nature. What it signifies is, initially we took V0 polarity like this, plus and minus, but now we will understood that V0 polarity will be like this, opposite to what we have assumed earlier. So hence in buck boost converter the output voltage will be always negative of minus dVs upon 1 minus d, that we have to remember. Or we can remember like this, its polarity is from the positive voltage comes at negative or lower plate of the capacitor, and negative terminal comes at the upper plate of the capacitor. Second thing that is to be noted is, when D duty cycle lies between 0 to 0.5, it acts as a step down converter, and for duty cycle lies between 0.5 to 1, it acts as step up DC converter. Hence buck boost converter is both step up as well as step down DC to DC converter. So the third parameter is the del IL, ripple in the inductor current. So when the switch is on, we have seen that the charging equation of the inductor is VL equals to del L into del IL upon dt. So ripple in the inductor current comes out to be Vs into d upon FL. 1 upon T is equals to the F frequency, that's why. Fourth parameter is IL, inductor current, IL max, maximum inductor current, and IL min, minimum inductor current. So for finding inductor current, we will use the capacitor charge gathered over it during the one complete cycle is 0, because for stability of capacitor, charge gained by the capacitor during the charging time must be equals to charge released by it during the discharging time. So del QC over a cycle is 0. Therefore IC on into T on plus IC off into T off will be equal to 0. So for that, now what is on time current? So we can see that whenever the switch is closed, this part of the circuit is isolated, so load gains the current or it is supplied with the help of the capacitor. So the capacitor charging current in positive plate will be equal to the minus of I naught, because load, we know that load has attained the positive polarity in this negative or lower terminal. Therefore the current flow like this towards the positive terminal. So now if capacitor is delivering the current in this direction, so this IC will be equals to minus of I naught in upward direction. So IC is minus I naught and IC off. Off time, when the switch is off, this inductor is charging capacitor and load both. So the capacitor current will be equals to IL minus of this I naught load current. Therefore IC equals to IL minus of load current. So now we put it in formula, minus of I naught into dt plus of IL minus I naught into 1 minus dt equals to 0. So from this we will get I naught, that is load current, will be equals to IL into 1 minus d. So therefore IL is equal to I naught upon 1 minus d. Second thing is IL max. Now we know that the inductor current waveform, that is triangular in shape. So this is the average value, this dotted dash is the average value of inductor current over the whole cycle. So for triangular waveform case, we know that average value is similar about its upper and lower peaks. Therefore this difference, if it is total del IL, then this above portion will be del IL by 2 and lower portion will also be del IL by 2 due to the symmetricity property of the triangular waveform. Therefore the IL max will be equal to IL plus del IL by 2 and IL min, minimum value of inductor current, will be equals to IL minus of del IL by 2. Now another way we can find IL, that is a short trick that is used by many of the students, that is we can use like that. If we want to find IL directly just by looking, then we can see that we have to find now IL in terms of load current. So we see that whenever the switch is on, the IL is flowing through inductor and source only. In between it is circulating like this. Only when switch is becoming off, at that time IL is flowing through the load. Therefore the off time waveform of the IL will be copied during the load time. That is I naught is equals to IL off portion only, this much portion only. So what is this portion value? That will be equal to IL into T off upon T. That is IL into this part is T off. This is T off. 1 minus D into T divided by total value. Therefore this T get cancelled and we will get I naught is equals to IL into 1 minus D directly, that we have got here. That is the short trick. So the fifth parameter is IS, source current. So for finding out the source current, we will now look at the general simplification of this inductor current waveform. That is, in many of the gate problem, they told that assuming ripple in the inductor current to be 0, because they tell that assume infinite or very large value of the inductor. Therefore for very large inductor, del IL will be 0. So the waveform will be simplified to a simple this dotted average value that I have drawn here, that is IL average. So we can see that whenever the switch is closed, at that time this is the IS that flows into the inductor source current and it charges it. But when switch is opened, the source is disconnected from the buck boost circuit. Therefore, the source current do not flow. So IL is on time IL inductor current gets copied in the source current waveform, and this off time waveform does not come in the source current. So what is this value? That we can find by simply averaging out the IL over the 0 to dt time only. Therefore, IS is equal to IL into T on, that is up to T on time only we have taken, is equal to IL into dt upon T. So tt gets cancelled. Therefore, IS will be equal to IL into D. The sixth parameter is ISW, I switch currents, average and RMS value. So when the switch is on, at that time the inductor charging current flows through it, and when the switch is off, no current flows through it. So the IL, similar to source current value IS, IL for 0 to dt, that is for T on time, that is copied in the ISW waveform, and for the T of time switch current is 0. So switch current average value will be equal to IL into T on, that is dt, divided by total time period. So tt gets cancelled and ISW switch current average value is equal to IL into D. Now I switch current's RMS value is equal to IL square into T on upon T whole under root. That will come out to be IL into root D. Seventh parameter is ID, that is diode current. For finding diode current, we can see that when the switch is off, at that time only the diode conducts. So the inductor current waveform for the off time dt to t can be copied in the diode current waveform, and for the on time of the switch it is 0. Now for finding this value of the diode current, we will see for average and RMS value. So first, average value will be equal to IL into T off divided by T, that is equal to IL into 1 minus dt divided by T. So Tt gets cancelled, so we get ID, average value of diode current, equals to IL into 1 minus D. Similar to buck and boost converter, same value for diode current, and RMS value comes out to be IL square into T of divided by T whole root, and that will be ID RMS equal to IL into root of 1 minus D. Till now we were finding the parameters IL, IS, I switch and diode current ID in terms of I naught. In gate questions, directly the load value current will be given I naught, or output voltage will be given and resistance will be given. So to find the value of I naught load current will be equals to output voltage V naught divided by the resistance of the load. Now we will switch to the 8th parameter, that is del V naught or ripple in the output voltage. So for that we will use the equation, charging equation of the capacitor. IC is equal to del Vc divided by del T into C. So we know that output voltage is same as the capacitor voltage. We have taken the same polarity also, plus at the lower plate, and this Vc is similar to the V naught. Therefore del V naught is equal to del Vc. So we also found out the value of capacitor current, that for on time is equals to minus I naught in the derivation of this IL, IL max and IL min. So for that, now we can substitute in this equation IC value, that is minus I naught is equals to C into del V naught, because del V naught and del Vc are equal, divided by dt. So from that we will get equation of the output ripple voltage. This is magnitude only, I have ignored the negative sign, which implied there is a decrease in voltage, output voltage for the on cycle. So del V naught is equal to I naught into D upon Fc. F is equal to 1 upon T. Now for the maximum value of the output voltage ripple del V naught, the value of the duty cycle required will be equal to 1 in the buck boost converter. So the 10th parameter is L critical. For finding out the value of L critical, I have drawn here the graph of IL, inductor current versus time, same graph. Now we know that del IL, that is ripple in inductor current, is inversely proportional to the L inductor used. So for L1 the graph is like this. For L2 the ripple will increase. So initially it was this much. So now it has increased to this much. Therefore the graph has shifted below the original position. Now suppose say for more less value of inductance L crit, this graph has just touched the zero line. For more less value of inductance L4, the graph will go more below, such that the conduction of the inductance will stop at this point and it will remain ideal for the time, this suppose say T1 to T. So such mode of conduction for L, value of inductance less than the critical value of inductance that we will derive will be discontinuous, and for L greater than or equal to LC, that is L1, L2 or L crit, the mode is continuous mode of operation. So in GATE question they will ask that whether it is continuous or discontinuous mode, then we can derive by finding out the value of L. So what is the value of L crit? Let's see. So for L crit we can see that this minimum value of current, inductor current is 0. So IL mean is 0. So IL minus del IL by 2 is equal to 0. So IL is equal to del IL by 2. But we know that IL is equal to I naught upon 1 minus D. Therefore I naught is equal to V naught upon R and into 1 minus D. Similarly, del IL is equal to VSD upon F into LC, that because it is the critical inductance case. So equating this V naught, now we write the V naught in terms of Vs upon 1 minus D. We have derived V naught is equal to Vs divided by 1 minus D into dVs. So substituting all the values, we get the final equation LC is equal to R into 1 minus D whole square upon 2F. This V naught is equal to D into Vs upon 1 minus D. I have simplified it directly here, so take care. The 11th parameter is C critical. Finding the C critical, we will use the same concept as previously. Vc mean is equal to 0. Previously it was IL mean is equal to 0. Now Vc minus del Vc by 2 is equal to 0. But we know that Vc and V naught are same. Therefore V naught is equals to del V naught by 2. Because V naught minus del V naught by 2 equals to 0. Now substituting the value of del V naught from the 8th step, that is I naught D upon Fc, and I naught is V naught by R. So V naught get cancelled. So we will get C critical Cc equals to D upon 2Fr. So let's look at the summary of buck boost converter parameters. So first is the VL, that is inductor voltage. That was when switch was on, that was plus Vs, and then the switch was off, that is minus of V naught. So inductor charges in on time and discharges in off time. Second is the output voltage V naught, that was minus dVs upon 1 minus D. We also saw the reason for this minus sign, because here the lower plate of the capacitor was charging because of this inductor current conducting in the diode from right to left. Third thing is the del IL, that is equals to the dVs upon FL. Fourth thing is the IL, that is equals to the I naught upon 1 minus D. IL max, that is the maximum value of inductor current, that is IL plus del IL by 2. Minimum value of inductor current, that is equals to IL minus of del IL by 2. Fifth thing is the IS, that was the source current. Source current was IL into D. because only on time source was delivering the current. Sixth thing was the ISW, that is switch current average value IL into D. RMS value is equals to IL into root B. ID, that is the diode current. Seventh parameter, that is similar to the derived in the boost and buck converter, that is average value is equal to IL into 1 minus D, and RMS value is equals to IL into root of 1 minus D. All this, both parameters, switch current and diode current, both average and RMS value is similar for buck boost and buck boost converters. That now the eighth thing, that is del V naught ripple in the output voltage, that was coming out to be I naught into D divided by FC, and at duty cycle 1 it becomes maximum. Now 10th thing is the L critical, that is critical inductance. Minimum value of inductor required such that the mode of conduction of this inductor becomes continuous, that we saw, that is R into 1 minus D whole square divided by 2F. And for L less than LC, the mode becomes discontinuous, we saw. Now 11th thing is secret, that is equals to D upon 2FR. Now friends, do not remember any of this formula, just remember the procedure, how we derived. It is only 30-second derivation, any of the parameter. So take a snapshot of this parameter and add it to your short notes. Now at the end, I would like to say you attempt the GATE previous year problems of the buck boost converter, and if you have any doubt, you can send me email on the description link given below. Best of luck for your exams and like the video.